I'm here at Auto Trader, a place where they trade autos, and while I'm not a massive car fan myself, I have heard they are very popular. I'm more about the mathematics, and when I was talking to some friends of mine at the Further Maths Support Program about how much I love maths and data because you can investigate things and it's fun and interesting, they said no, it's also very useful. They said that somewhere like Auto Trader still has to use maths to be able to go about their business, and so they've sent me here to meet someone who apparently uses maths to sell cars. Oh, hey, I'm Matt.
Sam.
Nice to meet you. Okay, so this is an office. Reminds me I've never had a real job, but okay, so you use maths in your work here?
Yes, I do.
Okay, I believe an office should have a meeting room or something, and we can talk that through.
Yeah, sure.
So. Okay, I guess technically, this is a meeting room. It's got a screen, that's kind of nice, and a switch. Oh, lights, right. Okay, so, anyway, Sam, what's your actual job title here?
So I'm a data analyst, and what that means is that I get all of the masses of data that Auto Trader has,
Right.
and I use that to help car dealers decide which cars to buy.
Actually, you know, could we make somewhere that's not an actual car? Yep. Okay, this is different. So, why does Auto Trader need a data analyst?
So we've got huge amounts of data, and we want to make sure that our dealers are going to be...
We are just in an aquarium, aren't we?
Yeah, kind of.
Has Auto Trader just regressed into becoming a startup?
It's actually quite a fun place to work.
Okay, right, so, okay, dealers, why do they want the data you're analysing?
So essentially a dealer buys a car because they want to sell it, and we have all of that information looking at what consumers are actually wanting to buy.
Oh, because you've got all the sales data and you can help inform dealers about what cars. I'm going to be honest, I'm not really paying attention right now. I'm thinking about my shot. Let's go somewhere more serious. Okay, now you're just having a laugh. Okay, Sam, so tell me about the maths you use.
So an obvious thing that we would look into first is if a car is getting more advert views, so more people are looking at it, does it sell faster? So we gather all of the data and then we'll just plot it all onto a graph.
That's it, you plot it?
We plot it.
There's not like some complicated software package that processes it and spits out like a correlation or something, you plot it?
We'll plot it. It's important to have a look at it first and just eyeball the data, because
Can you show me one of the plots?
Yeah, sure.
Okay, let's do that. Okay, you're actually opening Excel, and there's a plot. What is that?
Yeah, so we're having a look at the number of days on the site and comparing that to the average daily ad views that a car gets.
Okay, so that's the average number of views per day, and then this is how long it takes to sell the car.
Exactly.
And the cars which get fewer views every day take longer to sell.
Exactly.
That makes sense.
So one of the reasons that we'll put it into Excel is you can run this through programs, but you might miss things. So as we can see from this, you've got these
two random dots.
Two massive outliers, and they're going to be skewing everything. So we can eyeball the data and we can take them out.
So you then remove them.
Exactly, and it gives a much better fit.
That's nice. Although I'll be honest, the correlation between the more people looking at a car, the faster it sells, kind of makes sense. Right, is there anything a bit more surprising you've come across, something a bit more unusual?
So something that I'm working on at the minute, which had me completely flummoxed, was number of images that a car has. So I actually found that the fewer images a car had, the less time it was taking to sell.
That does not make sense.
It doesn't make any sense.
But there's a definite correlation between the two.
Yeah, definitely. So one thing that we found when we were looking into it is this beautiful plot here.
Right.
It's a bit confusing.
Oh, that's colourful.
So if we go over to this box here, we can have a look at all those cars that have been on the site for 10 days. And this is what percentage of the cars had a reasonable number of images on day 1, day 2, and we go along. And what we actually find is, regardless of how long the car takes to sell, it takes the car dealer a bit of time to get the images onto site.
Okay, so it's not that ads with fewer photos sell the cars faster, it's that cars that sell fast haven't had time to have the photos uploaded.
Exactly.
Because dealers put the cars online straight away, and then they take a little while. It looks like they take on average a week or so before a decent number have photos on the ad. That's so good. But if you hadn't plotted the data, you wouldn't have been able to spot that's what's actually happening behind the scenes.
Yeah, so what the fancy computer program was giving me back was that there was this correlation between the number of images and how long a car takes to sell, but it's obviously the wrong correlation. So once we've actually plotted it and had a look at it, we can see it quite clearly.
I'm going to be honest, when I was teaching A-level maths, teaching lines of best fit is tedious, my goodness. Right, and I quite like, there's some clever stuff you can do with regression and reducing the square, the distance and all that, but I didn't realize that people actually have to sit here and do that to check it. Okay, anything else that's not a scatter plot?
Normal distribution.
Of course.
So this appears in loads of places, and one of the key places that we see it is with one of our metrics.
All right.
So before I was saying that we help car dealers decide which cars to buy, and one of the metrics we use to do that is called desirability. And it's actually a score between 1 and 5, and it's normally distributed, but it looks a little bit weird.
Right, can we see it?
Yeah, definitely.
Oh, we can. Oh, the walls are whiteboards, of course.
So if we have a look
Yeah.
at what our metric looks like, we have 1 here.
For not desirable, 5 for very desirable.
Exactly.
Okay.
But what it looks like is it kind of looks like this.
Okay, so this is just the number of cars which have that desirability rating.
Exactly, yeah.
And the normal distribution makes sense in the middle, but you've got these ticks. Are they just a lot of really nice cars and a lot of terrible cars?
So what it is that if you have a look at a normal distribution, these tails will go out quite far.
Yep.
But because this is a score between 1 and 5, we have to cut them off. So all of these scores here are with 1 and below.
Oh, they're all the cars that would have been lower down, and you've just piled them all up on the bottom end. And these are all the cars that would have been out here somewhere, and you've piled them up.
Exactly, yeah.
So you've got to understand the shape of that distribution and some standard deviations, I assume. Right,
Yeah.
of course. To understand how relatively desirable one car is compared to another one.
Exactly, yeah.
So with all of these things, are you told what you've got to do with the data, or is it just kind of up to you to crunch it and see what falls out?
It's a bit of both, really. So it's quite a collaborative work environment. So we have innovation time every Friday. So we have half a day where we can just work on anything that we think obviously has to be a bit work relevant. But
It's going to be slightly linked to cars and data.
yeah, that we think's interesting, that we think could develop into something further.
And what was your background before you got into this?
So I came from a maths degree.
Of course. So you did maths A-level, maths degree, and then went into analysing data.
Exactly, yeah.
Okay, excellent. Well, thank you very much for your time. I'm going to go play with a few more of the cars. So it turns out you're allowed to write on the cars with whiteboard markers. I've never been so happy. But anyway, the maths has also been fantastic, and fairly obviously I'm going to go with S1 to look this up, because it's all well and good that Sam uses maths in her job. I wanted to make sure she definitely uses maths that she learnt at A-level. And so I've actually got a S1 textbook, and I don't think it's going to be a massive surprise that lines of best fit are going to be in here. And so let's have a look. Yep, there we are, almost. Okay, there's distributions. We've got normal distributions. I mean, it's all, I can absolutely mark off. Things like line of best fit, that's in there. Normal distributions, that's in there. And I guess most importantly, interpreting the data itself, because it's all well and good that Excel does a lot of this behind the scenes, but if she doesn't understand what it's doing and she can't interpret the results that come out the other side, she can't then make the data useful for the dealers who use the website. So there you are. I am completely convinced that Sam does use the maths she learnt at A-level in her everyday job. And I now have to clear out quite quickly because someone has booked this area for a standing meeting.